a plus ib, where real part is there, imaginary part is there. From where this imaginary part came, we realize that is square inside the root. If negative is there, we are not able to process that. Okay, hence mathematicians said that it is imaginary number. From there iota came. Okay, how to find the power of e and all we have already covered. So I think from class, very lower class, you started learning the concept of like number line. Okay, how to represent numbers on the number line. First you were calling it number line, and then you were representing it integers on it. Okay, a number line, and you used to represent integers on it. 0, then +1, then +2, then +3, here -1, here -2, -3. Later on, when you were just going in next classes, then you kept on learning that this is not a line where we can represent on like in number which is integer only. We can represent any number over here. Okay, any number, whole number, natural number, of course we can see, but integer of course we can see, but rational number also we can represent over here. Now in the next class, you realize that irrational number also we can represent on this number line, and hence this number line upgraded and we started calling it real line. Real line. Okay, why we are discussing these concepts over here in complex number chapter? We are discussing it so that we can relate the concept. Okay, so here complex number also we can represent it, but there is a argand plane, we will be calling it. We have taken two lines, one number line. Okay, the previous one, suppose this line we have taken and another line we have taken, same 0, 1, 2, 3, here -1, -2, -3, and this time what we are doing, no, we are writing I with each of the number. We are trying to create a imaginary line. Okay, so what we will do, instead of 1 we will be writing 1i, instead of 2 we'll be writing 2i, instead of 3 we'll be writing 3i, 0i you can say, -1i, -2i, -3i, and this way we are saying that with the concept we already know about number line, we have created one imaginary line. Now with the help of this, the first line which is very familiar to us, and the second line, we are going to create a plane, and this way we will be creating a plane with the, this is 0, 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is -1, -2, -3, -4, and here 1i. Okay, here 2i, here 3i, here 4i, here 5i. Okay, here -1i, here -2i. So we have taken a real line and a imaginary line, and we have created something like a Cartesian plane. Okay, we are going to call it argand plane, and here we will be able to represent our complex number. If we will be having a complex number 3 plus 2i, no, 3 plus 2i, that means real part is 3. Let's locate it. That means real part is 3, which we are going to search on the real line, and imaginary part is positive 2i. So this is the point which will represent 3 plus 2i you can say, or in short we can also write it, it is nothing but just 3 comma 2. Yes, we can write it as a 3 comma 2. Okay, so whenever in coordinate form any complex number will be given to you, no, 5 comma 7, you should understand 5 is the real part plus 7i is the imaginary part. Okay, this is how we can create a complex number. And when the complex number is given, suppose the complex number is given as a, let me take a smaller number, suppose a complex number is given as a -1, -3i. Okay, and we have to represent it in argand plane, where we can represent any complex number. So real part is -1 here, and imaginary is -3i, which is somewhere here. So this is the point which represent -1 -3i, which in short can be written as -1 comma -3, where the first coordinate which we used to call that time x coordinate is representing the real part, and the next one y coordinate is representing the imaginary part. Getting it, Ali and Alina? Are you getting it?
Yes, ma'am.
Yes, ma'am.
Okay. So yeah, this is how we will be representing it. Now instead of this I and all, even if we can write it like this only, just like the coordinate system, this is 1, this is 2, this is 3, this is 4, this is 5, and this is also 1, 2, 3. We will understand by default. Now we will understand that this y-axis now here is working like a, in complex number chapter, this y-axis is a imaginary axis. Okay, and this x-axis is a real axis. Okay, so even I, sometime you will find that I is not written over there. It's completely okay. I is there. Okay, I is there. Even if it is not written, I will be there. We will take I by ourselves. If any point will be given like this and it will be just written like this 2 comma 2, and we have to take a complex number, we have to take this in the form of complex number, we will take it by ourselves. It is nothing but 2 plus 2i. Okay, so always in this argand plane, whenever any complex number is located, I, even if I is not, you can't see I, you have to take I by yourself. You have to understand y axis is the imaginary axis. Okay, now we are supposed to discuss here the modulus, concept of modulus. Just a second. Yes, modulus, and this means distance from origin. Distance from origin. So suppose we are having argand plane and a point is there. Suppose a point is there, P, over here, and that point's coordinate is a comma b. In form of complex number, if we have to write it, we understand it is nothing but a plus bi, right? Ali and Alina, right?
Yes, ma'am.
Okay. Now only we realize that modulus means nothing but distance from origin. Modulus is nothing but distance from origin. So this P point distance from the origin, that distance, if we will be able to find, that is called modulus. Okay. Now, if you will focus, if we understand that coordinate geometry we have learned so well, and we can use that concept over here, we can say that we understand this much distance is B, and we understand this much distance is A. Yes or no? Yes or no? Ali and
Yes.
Alina, if any coordinate is given like P, that is A comma B, we can say the vertical distance this much is B, and this much the horizontal distance is A. Okay. So what we have to find here, we have to find OP. We have to find OP. So Pythagoras theorem we can use. We can say that OP square is nothing but A square plus B square, and OP is under root A square plus B square, right? Right? OP is nothing but under root A square plus B square. Whenever any complex number will be given, see, here we have taken a complex number A plus IB. Here we have taken a complex number A plus IB, and that's distance from origin is under root A square plus B square. That means we understood that any time any complex number x plus iy will be given, then distance from origin will be, okay, we will represent it with mod, also mod of z, because z we use to represent any complex number. So mod of z will be nothing but under root x square plus y square. This is the formula. Okay, basically we, it just came from the basic concept. If suppose our complex number, our z looks like this, z is equals to 3 minus 4i, then what to do? Then mod z, how we'll be finding? Mod z means distance from origin. Okay. Then why in modulus function we were talking about something else? And here we are saying modulus is distance from origin. See, modulus, let me help you recalling the modulus function. We understand if suppose mod of x is equals to 5, then x value, the possible value of x maybe x is 5 or maybe it is minus 5, right? Then only mod will give the positive answer. That's how we have learned this function, right? Right, Ali and Alina? If mod x value is 5, then maybe x is 5 or maybe x is minus 5. Yes or no?
Yes, ma'am.
Yes. Okay, maybe x is 5 and maybe x is minus 5. So on number line, if I will draw a real line, 0, 1, 2, 3, 4, 5, here minus 1, minus 2, minus 3, minus 4, minus 5. Okay, modulus is 5. Then x is 5 or maybe minus 5. Can you see distance from origin only? This minus 5, this point's distance from origin is 5 unit, or maybe this 5, this point's distance from origin is 5 यूनिट. ये दोनों ही एक ऐसा पॉइंट है -5 या फिर 5 जिसका डिस्टेंस फ्रॉम ओरिजिन 5 है. And hence we have got this 2x value, we have figured it out. Is it making sense to you? Is it making sense to you? Mod of x means 5. That means if x value is minus 5, distance of mod means distance from origin, and minus 5 means distance of minus 5 from origin. Is it 5? Is it 5 unit? Yes or no? Yes or no?
Yes, ma'am.
या फिर नाउ ओनली वी से दैट x का वैल्यू तो 5 भी हो सकता है कि x का वैल्यू 5 है. तो अगर x का वैल्यू 5 है और उसका मॉड है, तो ध्यान से समझो, डिस्टेंस ऑफ दिस डिस्टेंस ऑफ द नंबर 5 from origin, is it 5? Yes, it's 5.
Yes, ma'am.
So mod का मतलब ही तो डिस्टेंस फ्रॉम ओरिजिन होता है. पहले हमने रियलाइज उतना नहीं किया था. नाउ वी आर एबल टू ट्राई, वी आर जस्ट ट्राइंग टू कनेक्ट द कंसेप्ट कि अचानक से कैसे बोल रहे कि मॉड का मतलब डिस्टेंस फ्रॉम ओरिजिन होता है, तब तो नहीं बोला था. बट इट इज दिस कंसेप्ट is working over there also. Okay, that time it was that simple, that's why we were not talking about it. This time we are getting a distance from origin like a hypotenuse, hence we are discussing about it. Okay, so mod का मतलब ही distance from origin होता है. यहाँ कॉम्प्लेक्स नंबर में वो whenever we are trying to find the distance from origin, कुछ hypotenuse right angle triangle मिल जा रहा है हमें, और वहां से एक फॉर्मूला निकल के आया कि जब भी हमें mod x mod z फाइंड करना होगा, मॉड्यूलस ऑफ एनी कॉम्प्लेक्स नंबर फाइंड करना होगा, तो सबसे पहली बात कि वो a प्लस आई बी के फॉर्मेट में रहे. उसके बाद हम लोग क्या करेंगे, फॉर्मूला बोल रहा है कि रियल पार्ट का होल स्क्वायर कर दो एंड प्लस इमेजिनरी पार्ट जो भी है, जो हमने फर्स्ट क्लास में क्लियरली डिस्कस किया था, रियल पार्ट इमेजिनरी पार्ट कैसे फाइंड करते हैं ऑब्जर्व करके. तो फॉर्मूला में वही है, रियल पार्ट होल स्क्वायर प्लस इमेजिनरी पार्ट होल स्क्वायर. यही तो मॉड्यूलस का फॉर्मूला है. मॉड्यूलस का मतलब क्या है? मॉड्यूलस का मतलब डिस्टेंस फ्रॉम ओरिजिन है. गॉट इट? इज इट क्लियर, अली एंड
Yes, ma'am.
अलीना? If it is clear, then let's do this question. If z1 is equals to 2 minus I and z2 is equals to 1 plus I, find modulus of z1 plus z2 plus 1 over z1 minus z2 plus 1. z1 एक कॉम्प्लेक्स नंबर है, z2 दूसरा कॉम्प्लेक्स नंबर है. We have to find the modulus of the given expression. अब जो given expression है, let's try solving it and let's try writing it in the form of a plus ib. Then only we will be able to find the modulus of the same. Okay, let's do it. z1 plus z2. Okay, z1 is 2 minus I. I am just substituting the value. z1 के place पे 2 minus I we will substitute. Check it. Just a second. No, 2 minus I and z2 के place पे z2 already given एक दूसरा complex number, that is 1 plus I plus 1 over again z1 is 2 minus I, z2 is minus of 1 plus I plus 1. Okay, let's try simplifying it. So when we will open the bracket, this minus I and plus I cancelling each other, yes or no? Ali and Alina.
Yes, ma'am.
Okay, basic simplification हमें करना है यहाँ पे. 2 plus 1 plus 1, 2 plus 1 3, 3 plus 1 4, 4 over 2 minus I minus 1 minus I plus 1. Is it getting cancelled out? No, now it is not. Like nothing I can see. It's, yeah, 1 and 1 is going. Minus 1 plus 1 0. So basically we are having 4 by 2 minus 2i. Is it so?
Yes,
Is
ma'am.
it? Let's continue. 4 from denominator we can take out 2 common. Why we'll be doing so? So that we can cancel the numerator. Something we can cancel. So 1 minus I. Okay, 2 times 4. Okay, so we ended up getting 2 by 1 minus I. Now I said to you, first we need to have the form, the basic complex number form, a plus ib format. Then only we can think about finding the distance of origin. Okay, distance from origin of that particular point. So 2 by 1 minus I को a plus ib के format में लिखना है. Do we know that? Yes, we know that. Okay, rationalization concept we have used so much, like in previous class also we have done so much of simplification, so many questions we have done. So we can use that concept. 2 multiplication of 1 plus I and 1 plus I. Is it allowed over here? Oh yes, it is allowed because you are not doing any changes. See, 1 plus I multiplying in the numerator and denominator, it means you are just multiplying 1. Okay, so we are not doing any drastic change. See, we ended up getting 2 in bracket 1 plus I in the numerators part, and in denominator a plus b, a minus b structure we have generated. So a square minus b square. We know that here we'll be doing now. We know that I square is nothing but, Ali and Alina, I square value is what? Ali and Alina.
Minus 1.
Yes. So 1 minus of minus 1. We got, you can multiply this 2 and I so that we can have what is real part, what is imaginary part over. Okay, 2. Better not to multiply because this denominators 2 will cancel the numerators 2. Okay, don't multiply. 2 which is sitting outside, it is working. In denominator 1 plus 1, 2. 2 gone, and we are left with just 1 plus I. Now we have to find the modulus of this complex number. Yes, we know real part whole square inside the root a square plus b square. That means a is the real part. What is real part over here? Ali and Alina. Yes. What is real part? Is it 1 square plus imaginary part is what? Please tell me, Ali and Alina. It's that simple. 1 plus I का real part क्या है? Imaginary part क्या है?
I का imaginary part 1 है.
Yeah, what?
Imaginary part is 1.
1. Okay, this is the modulus. Modulus of whatever was asked, 1 plus I will be this. Okay, is equals to under root 1 plus 1, that is root 2. And we are done. This is the modulus of the given expression. Is it clear, Ali and Alina? We were having two different complex number. One expression was given and we were supposed to find the modulus. When I explained you the concept of modulus, then I told you that modulus means nothing but distance from the origin. But we must have a plus ib format. Okay, a complex number we must be having, then only we can think about finding the distance from the origin. And directly we will be using the formula every time. Mod of z formula is x square plus y square. We realize the formula is real part whole square plus imaginary part whole square. Why we are writing formula like this? Because complex number x plus iy, or maybe sometime you can have 2 minus 3i. Okay, that's why here in detail I have written that real part is square plus imaginary part is square, that 2 inside the square root. Okay, because your complex number can look like 2 minus 3i. That time you will be doing 2 square plus minus 3 whole square. Okay, so modulus we understood. Now we have to find the modulus of the given expression. We just simplified the given expression. We kept on doing the simplification and we ended up getting 1 plus I only. And we found the modulus of that. Any confusion, Ali and Alina?
No, ma'am.
Okay, if it is clear, then we'll be solving the... Just a second, let me check anything else. Yeah, now we'll be discussing the conjugate, the concept of conjugate. Conjugate of any complex number. Okay, what does it mean? Now, please don't get confused in between multiplicative inverse, modulus, and conjugate. Please don't get confused. Multiplicative inverse, the meaning was very clear. Okay, z, the multiplicative inverse of z will be 1 by z. 1 by z, which can be written as like whatever complex number will be given, we can write it 1 by, if a plus ib is there, if 3 plus 4i is there, that we can write it in the denominator. And then we just try doing the simplification to write it in normal form of complex number. That's it. That was inverse, multiplicative inverse. Modulus, distance from the origin, and conjugate means image along x-axis. Okay, so suppose we are having a same argand plane I am drawing. Suppose there is a point P that is a comma b. We understand whenever in complex number this a comma b will be there, that means nothing but a plus ib. Okay, a plus bi. Okay, now image of this point p on x-axis. Here we'll be having the image of that particular point will be here. Okay, that point you can call it p dash. Here you can understand x coordinate will not change, but y will be just the same with negative sign. So a plus ib or a plus bi just change to a minus bi. Image of this complex number is this complex number, and image of this complex number, see, दोनों एक दूसरे का इमेज है. ओके, a प्लस आई बी का इमेज है a माइनस आई बी, और a माइनस आई बी का इमेज है a प्लस आई बी. ठीक है, दोनों एक दूसरे का इमेज है. दिस इमेज इज कॉल्ड कॉन्जुगेट ऑफ कॉम्प्लेक्स नंबर. Okay, we represent this with any complex number, we represent with z, और इमेज को हमेशा हम लोग रिप्रेजेंट करते हैं z बार से. अगर ये z ही दिया हो a माइनस आई बी, सपोज z बार नहीं, z एक्चुअल कॉम्प्लेक्स नंबर ही a माइनस आई बी दिया है, तो उसका इमेज होगा a प्लस आई बी, और इसे z बार बुलाएंगे. ठीक है, तो कैसे निकालते हैं इमेज? तो जो भी इमेजिनरी पार्ट है उसके सामने एक नेगेटिव साइन खुद से दे देते हैं. लाइक सपोज यू आर हैविंग 2 प्लस 3i, इसका कॉन्जुगेट क्या होगा? कॉन्जुगेट, सो कॉन्जुगेट होगा, i को माइनस आई से रिप्लेस कर देते हैं. ओके, बेसिक कंसेप्ट इज लेट्स रिप्लेस i विथ माइनस आई, सो कॉन्जुगेट विल बी 2 minus 3i. Okay, now suppose you are having a complex number, a given complex number is 5 minus 3i, and conjugate you have to find. Conjugate means image on x-axis. Conjugate you have to find. Conjugate of this complex number will be, just replace I with minus I को minus I से replace कर देंगे, तो यहाँ तो plus 3i create हो जा रहा है. Yes, that is the conjugate of 5 minus 3i. Are you getting it? बट क्वेश्चंस ऐसे स्ट्रेट फॉरवर्ड नहीं आएगा. ये तो हुआ कंसेप्ट. अब फिर से हमसे क्या कराएगा? सिंप्लीफिकेशन, और तब जाके हम निकालेंगे कॉन्जुगेट. सो लेट्स टेक वन क्वेश्चन. फाइंड द कॉन्जुगेट ऑफ 3 minus 2i, 2 plus 3i, 1 plus 2i, 2 minus i. Okay, we are supposed to find the conjugate of this complex number. First we will try simplifying it, then we will try writing it in the standard form a plus ib. Okay, then I को minus I से replace करके conjugate find करेंगे. Let's do it. चलो पहले simplify करते हैं. हमारे पास क्या है? We are having 3 minus 2i. We are having 2 plus 3i. We know distributive property is allowed over here. Okay, over 1 plus 2i, 2 minus I. Let's apply distributive property. We'll be having 3 will get multiplied with 6, 2. So it will be just 6, 3, 2 times 6. Then what will be having? Ali and Alina, please tell me. Yes, Ali and Alina. What we will be having in the numerators part? 6. Then
minus 6.
then yes, minus 6i will be there. Then
9i plus 9i.
then
minus 6i square.
3 you multiplied with 2, that is 6. 3 we need to multiply with this also. 3 times 9, yeah. Minus 2i we will multiply with 2, that is minus 4i, right? And minus 2 will get multiplied with plus 3i, 6 minus 6, I square. Is it okay? Ali and Alina? Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, 1 will get multiplied with 2. 1 will get multiplied with minus I. 2i with 2, 4i. And 2i with minus I, minus 2i square is equals to 6 minus 4i plus 9i minus 6i square. That will be minus 6i square is nothing but minus 1. Okay, we could have done the addition also parallelly. Why we are not doing? Let's do it. Because simplification we understand it very well. 6 minus 4i plus 9i, 5i. 6i square, it will be minus 6. I square is nothing but minus 1. Over 2 minus I plus 4i will be, yes, Ali and Alina. Minus I plus 4i is plus 3i, right? And it will be minus 2. I square is minus 1. Let's continue. We will be having 6 plus 5i plus 6. Okay, 2 plus 3i plus 2. 6, 6, 12 plus 5i. 2, 2, 4 plus 3i. Okay, let's continue. Now we will do the rationalization. This 4 plus 3i, this one. We can multiply 4 minus 3i in the numerator. Okay, to create a standard form of complex number, for that we need to remove this I from the denominator. That's why we are applying this approach. Okay, so we will be having 4 plus 3i, 4 minus 3i, that means a square minus b square. In numerator, we'll be having 12 plus 5i multiplied with 4 minus 3i. Okay, let's do it. In denominator, we are going to have, please tell me which number we'll be having in denominator. Yes, Ali and Alina.
16 minus 9i square.
16 minus 9i square, I square is minus 1. So we can say 16 plus 9. Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
numerator it will be 12 4 times 48. 12 3 times 36 minus no plus 20i minus 15i square, right? Let's try simplifying. Denominator is just 25, numerator is 48, minus 36 plus 20 is minus 16i, minus 15i square will be plus 15. Okay, let's continue. We are going to have 48 plus 15. 48 plus 15 is what? Please tell me quickly. Please do the addition and tell me.
I'm at 63.
52, 3, 63. Is it 63? Ali? 8, 5. Yeah, it is 63, right?
Yes, ma'am.
Okay, now real part, imaginary part, we need to write it properly. So we know how to do so. 63 by 25, this is the real part, minus 16 by 25 I, this is the imaginary part. Okay, now the question was not to simplify it, the question was to find the conjugate of it. We understand conjugate of this a plus ib will be a minus ib, or we understood that every time while finding the conjugate we have to replace I with minus I with minus I को minus I से replace करेंगे तो conjugate मिल जाएगा. So let's find conjugate. 63 by 25 minus I के place पे minus I लिखेंगे. Okay, so conjugate क्या मिलेगा? 63 plus 16 by 25 I. Is it so? Yes or no, Ali and Alina? तो फिर ऐसे आएंगे क्वेश्चन एग्जाम में. कॉन्जुगेट निकालने के लिए एमसीक्यू क्वेश्चन वेरी इट कैन बी सिंपल दैट व्हाट इज द कॉन्जुगेट ऑफ 5 plus 4i, that is just 5 minus 4i. You can mark the correct option, and or maybe it can come in coordinate form that the conjugate of this will be, you will say it will be 5 minus 4. Okay, so question can come in MCQ portion like this, but exactly you can expect this type of question that first we are supposed to simplify it and to write it in the form of x plus iy, a plus ib, the standard form of a complex number, and then we need to find the conjugate. Is it clear to you, Ali and Alina?
Yes, ma'am.
Let's do a few more questions. If x minus iy is equals to under root a minus ib over c minus id, then prove x square plus y square whole square is equals to a square plus b square over c square plus d square. If x minus iy is this, then prove that this is equals to that. Okay? Okay. If we have to prove that x square plus y square whole square, can we say x square plus y square? इतने सारे क्वेश्चन सॉल्व करने के बाद एक आइडिया तो हमें हो गया कि x प्लस आई वाई से एक्स स्क्वायर प्लस आई वाई स्क्वायर कैसे क्रिएट कर सकते हैं. इतना तो हमें समझ में आता है. इतने सारे क्वेश्चंस में हमने रैशनलाइजेशन किया. ओके, डेनोमिनेटर से आई रिमूव करने की कोशिश की, एंड वी अंडरस्टूड दैट अगर कुछ ऐसा दिख रहा है कॉम्प्लेक्स नंबर तो ये वाला एक्सप्रेशन कैसे क्रिएट कर सकते हैं. ओके, सो x प्लस आई वाई में, वेट, x माइनस आई वाई में अगर हम लोग मल्टीप्लाई कर देंगे x इसके कॉन्जुगेट का, दैट इज x प्लस आई वाई, तो कुछ ऐसा क्रिएट कर पाएंगे क्या एक्स स्क्वायर प्लस वाई स्क्वायर? यस और नो? अली एंड अलीना, अली एंड अलीना,
Yes, ma'am.
एक्स स्क्वायर प्लस वाई स्क्वायर क्रिएट कर पाएंगे क्या अगर x माइनस आई वाई जो गिवन है उसी में उसका कॉन्जुगेट मल्टीप्लाई कर दे तो? हाँ या ना?
हाँ, ma'am.
हाँ, ठीक है. तो इतना तो समझ आया. जो प्रूफ करना है वो कैसे करे, कहाँ से स्टार्ट करे, समझ नहीं आ रहा है. इट इज रिटन ओवर हियर एक्स स्क्वायर प्लस वाई स्क्वायर एंड दैट साइड ए स्क्वायर प्लस बी स्क्वायर. हाउ टू break them, how, what to do over here, we are not getting. Then we came to a point that when we'll be just multiplying the given complex number with its conjugate, then we'll be able to generate the left hand side. Okay, we will be able to generate x square plus y square, just that. Not a square. This square is still we have not figured it out. This is square. But from this two we are getting x square plus y square. So let's try thinking about x square plus y square at first, and then the complete square and all we will see. Okay, so let's take the given complex number. x minus iy क्या दिया हुआ है? अंडर रूट a minus ib over c minus id. Now we are trying, this is equation 1 which is already given. C minus id was there. Yeah. Now in this we want to multiply on the left side x plus iy. Okay, so we are finding the conjugate on the left side, or we are replacing I by minus I. It's the same thing. Okay, replacing I by minus I, or you are saying the terminology conjugate, it's the same thing. Replacing I by minus I. अगर कुछ ऐसा करे तो let's do it. एक न्यू इक्वेशन हम लोग क्रिएट कर पा रहे हैं यहाँ से. This will become x plus iy and this will become a plus ib and this will become c plus id. ये एक न्यू इक्वेशन क्रिएट कर पा रहे हैं हम लोग. I को माइनस आई से रिप्लेस करके एक न्यू इक्वेशन क्रिएट कर रहे हैं हम लोग. ओके, now we will do the multiplication of equation 1 and equation 2. Why? Because this part is clear to us. Let's do the multiplication. X plus iy into x minus iy. अब हमें ये देखना है कि हमारा राइट हैंड साइड भी जो प्रूफ में दिख रहा है वैसा कुछ आता है या नहीं. ओके, लेफ्ट हैंड साइड तो बड़े ही अच्छे से हमने अरेंज कर रखा है. ओके, लेट्स सी द राइट हैंड साइड. सो a minus ib by c minus id was there. Root a minus ib over c minus id multiplied with another root a plus ib c plus id. Okay, now what we'll do, we will take everything inside one root sign and it is nothing but a minus ib, a plus ib, which seems like we'll be able to do the multiplication. Like the identity we can use, a minus b, a plus b type of structure we are getting. A c minus id, c plus id. Writing both the part in one root, is it allowed? Oh yes, it is allowed. You have seen this type of concept that root 2 into root 3 is nothing but root 6. Okay, root 2 into root 2 is nothing but both came in one root, made the pair just 2. We know that, right? Ali and Alina?
Yes, ma'am.
Okay, so on the left side we are getting x square plus y square, and on the right side this is something we are getting. Let's try simplifying it. We will be having a minus ib, a plus ib, it is just a square minus ib's, that's whole square. In denominator c square minus id's, that's whole square. Okay, let's continue. We will be having a square, this I square b square, it will be minus of minus 1 and then b square, that means plus b square, over c square plus d square. Are you getting it? Any confusion so far, Ali and Alina?
No, ma'am.
Okay, now what we need to prove? X square plus y square whole square is a square plus b square by c square plus d square. Oh yes, it is. Can you see, it is x square plus squaring both sides we will do, and we are done with the proof. Yes or no?
Yes, ma'am.
Okay, squaring both sides and we are done with the proof. We are done. So let's summarize. सबसे पहले कुछ ऐसा कॉम्प्लेक्स नंबर, कुछ ऐसा एक्सप्रेशन दिया हुआ था x माइनस आई वाई इसके इक्वल है a minus ib, c minus id, under root and all. This was given to us. Okay, and this is what we are supposed to prove over. Now we are thinking. Just by looking at the proof, we are thinking. What can be done over here? So right side completely we are not getting. Left side we realize that x square plus y square we can create by multiplying the conjugate of x minus I, or by multiplying, first we will replace I by minus I, and then we'll be getting x plus iy, that we can multiply in this left hand side, and then we'll be able to get x square plus y square. So we did the same, the given equation and one equation we made it. We are just writing at the place of I, we are writing minus I. Okay, we can call it conjugate. This is just the image of the previous one, and then we are doing the multiplication of both. Once we are doing the multiplication, we realize that we are done with the proof, right? Are you getting it, Ali and Alina? Okay, your internet is on not stable, Ali. No worries. Let me check. Okay, it's already 26 today. It was of 1 hour class. Let me check anything quick we can do, or I can give it to you.
Can you tell me the answer? I need to write.
Yeah, answer will be squaring both sides. It will be x square plus y square. That's square is equals to, without root we'll be having here, because we have done the square and root and square root cancelled each other. This is what we are having, and hence proved.
No, I meant, can you scroll up?
Yeah. Is it okay or more?
More.
This is okay, Alina?
Yes, ma'am.
Okay, you just kept on telling me, I'll be scrolling.
Ma'am, scroll down. I'm gonna scroll down. Done, ma'am.
Done?
Yes, ma'am.
Okay, so please do this question. Not now, at your home you try doing it. We will start our next class with the same question. 1 plus I, 1 minus I, minus 1 minus I, 1 plus I. This one. Find the modulus of this. Okay. Conjugate and modulus we have, you understood. Okay, we'll be solving few more questions and then we are done with this topic. Okay, this